Hello everyone, we're back with dihybrid crosses today. So we finished monohybrid crosses where we were dealing with just one trait, and now we're going to get into dihybrid crosses, and this is a type of inheritance when we are looking at crosses that involve two traits. There are such thing as trihybrid crosses or tetrahybrid crosses, but for the purpose of this course, we're not going to go through those. So these crosses that involve two traits. So what do I mean by that? So for an example, we could be dealing with hair color and eye color. What are the probabilities of someone with brown hair and blue eyes mating with somebody with blonde hair and brown eyes? What are the probabilities or the genotype and phenotype ratios of their children? So now we're dealing with two traits at a time. But before we do that, let's look at a little bit of review first. So we need to remember that so far, we've seen two laws from Mendel. So we saw the first law from Mendel was the law of segregation. And remember, the law of segregation stated that when gametes are being formed, the parents will provide one allele for those gametes. So when we were looking at crosses, I would always say, remember that one comes from mom, one comes from dad. And that's because of the law of segregation that Mendel brought forth, that whenever you're making gametes, if you're heterozygous for your condition, if you have a big B, little b, half of your gametes will get the big B, half of your other gametes will get the little b. So that's the law of segregation. The second law that we saw was the law of dominance. And the law of dominance is stated that whenever you have a dominant recessive type of inheritance, so this is the very first one that we did, if you inherit a dominant allele, that dominant allele will mask the recessive. So if you're again heterozygous, big B, little b, it doesn't matter that you have a little b, that will not show up in your phenotype. So that particular genotype, because you do have a dominant allele, that dominant allele will mask the recessive. So that's the law of dominance. Now the third law that we're going to look at when it comes to Mendel has to do with dihybrid crosses. So the third law that we're going to examine is called the law of independent assortment. And the law of independent assortment, what it states is that, let me make a little arrow here, genes for different traits, eye shape versus my widow's peak, the hairline, for example, so genes for different traits will sort differently or separately from one another. I like that word better. I like the word separately better than differently. So we're just going to put separately. And are not dependent on each other. So if you remember in anaphase of meiosis, when our gametes are forming, so the very first meiosis, when our chromosomes are lining up in the equatorial plate, the way that they line up, mom, dad, mom, dad, mom, dad, that's all going to be separate. And so that's what they're talking about. The genes for different traits will sort themselves separately from one another. They're not, they don't have a relation with one another in the way that they sort. So for the above cross, so for a dihybrid cross, let's assume that we have a couple of parents that are purebreds. and let's give them some characteristics. So let's say that I have, I'm going to do my little legend here. So I'm going to say, so big B is going to be brown eyes, and that's dominant. Blue eyes. And I'm going to go big H for, let's say, brown hair. Oops. And little h for blonde hair. Okay, just letters at random. It doesn't really matter here. We're just establishing the fact that brown eyes and brown hair is dominant over blonde hair and blue eyes. Okay, so let's start with parents. And we said that both parents are purebred. So I'm going to have a parent that has brown eyes and brown hair, and I'm going to cross it with a parent that has both the recessive. Okay, so let's state that here. So this particular individual has got brown eyes and brown hair, and this particular individual has blue eyes and blonde hair. Okay. So now we have to figure out what would these parents give to their gametes. So we're looking at the law of segregation here. So if this is, let's say, is the dad, okay, so this guy is going to be making sperm, and this is mom's going to be making egg, then what are the possible alleles that that parent can give that gamete? What is the possible genotype that that gamete could have? Well, the only thing dad can give here for B is a capital B, and the only thing that he can give for H is a capital H. Mom can only give a little b and a little h. So now I have the egg and sperm, right? And these guys are going to come together in that process that we know as fertilization. And as a result, I'm going to have a zygote. I'm going to have a baby. Now, when you're making the genotype of the zygote, what you want to do is you want to keep the letter groupings together. And again, capital letters go in front of lowercase letters. So here I have big B, little b, and big H, little h. So if these were my parents right here, right? So if that's what the parents could give, then these would be my F1 generation. So my F1 generation, all of the babies that those two parents can have are hybrids. But in this case, they are called dihybrids. Okay. They are hybrids, they're heterozygous for both of those traits. So they are dihybrids. Okay. Now what if I were to take two of those dihybrids and cross them together? Okay, so I'm going to say, what if I crossed two individuals from the F1 together? Okay, so let's have a look at that. Big B, little b, big H, little h, crossed with, again, another dihybrid. Again, what I have to do here is I have to figure out the gametes, okay? So in order for me to figure out the gametes, egg and sperm, I have to see what kind of combinations can we get, okay? And I'm gonna give you a hint just by drawing this, that you're going to get 4 different combinations. Now, how do I figure out the combinations here? It's almost like a FOIL in math, where you go, you know, this with this, and then big B with little h, and then I can do little b with big H, and little b with little h. Okay, so we have to have those different combinations. So I can have both of the capitals, one capital, one recessive, and then I'm going to switch it up, the recessive with the capital, or the dominant, and then the two recessives together. So now you can see how I can have those different possibilities. And the same is going to go for this parent, big H and big B. And now I have the 4 different. So now when I'm doing a Punnett square, for this one, it's going to be a gigantic, a 16 square Punnett square, because each one of the sides of the Punnett square needs to have the alleles that the gametes bring forth. And so I'm going to be making that Punnett square. And again, I'm going to put big H and big B. And then we're combining them together. So remember, this is the same thing that we had with the regular Punnett square, but what we're doing is we're doing 2-letter groupings. So big B, big B, big H, big H. Continue filling this. All right, so now we have the giant Punnett square. Again, we're keeping our letters together, following that. And now we're going to look at a phenotype and a genotype ratio. Okay, so when you're looking at this, might start maybe with a phenotype ratio, and I might go, okay, so what I need is, what are the different phenotypes here? So I can have brown and brown. I can have brown hair and blue eyes. I can have blonde and brown. And I can have blonde and blue. So those are the different combinations that I can have. So now it's up to me to look at that Punnett square and see, okay, let's see how many. So how many here are going to be brown and brown? Okay, so brown, 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 brown. That one's brown. So as long as I have a capital B and a capital H, that will be brown for both. And there's one more. So I have 9 brown hair, brown eyes. Now I have brown and blonde. So I need to have, brown and blue. So I probably should have switched these just to make it a little bit easier, because we did the color of the eyes first. So let's see, I'm going to switch these. Hopefully it's not. Okay. And then we're going to do blue eyes and blonde hair. Sorry. That'll make it a lot easier for us to find. So I need blue eyes and brown hair. So now what I need for blue eyes and brown hair, I'm going to choose a different color. I'm going to go with this color. So I'm going to need the 2 little B's, but a big H. So I need 2 little B's, big H, 2 little B's, big H, 2 little B's, big H. So I'm looking at 3 there. Another color. So now I need brown and blonde. So I need to have big B, but 2 little H's. So that's 1 and 2 and 3. And then the last one, I need recessive for both. So in this case, what I need is I need to have 2 little B's and 2 little H's. And so that's 1 right there. So now I have my phenotype ratio, which is a 9 to 3 to 3 to 1. Now, this is always going to be the case for dihybrid crosses. So anytime that you have 2 heterozygotes that are crossing together, you're always going to have a phenotype ratio of 9 to 3 to 3 to 1. So whenever you have 2 heterozygotes crossed, okay? So that's the case for that. Now, you're probably asking yourself, well, what about the phenotype? You give us the phenotype, what about the genotype ratio? Now the genotype ratio is also going to be a 9:3 to 3:1, depending on how you write it. So the hint here is if I do, it's a 9:3 to 3:1. So this is for the genotype. This one was the phenotype ratio, okay? So it's a 9:3 to 3:1 because 9 are gonna have a big B and a big H. Doesn't matter what the other one is. 3 are going to have the capital B for one and 2 little h's for the other. 3 are gonna have the little lowercase b's and a capital H, doesn't matter what the other. And 1 is going to have 2 little b's, 2 little h's. So in this case, that is also always the case for dihybrids for heterozygotes. Now this is the case for dihybrids that are just a dominant recessive cross. We're gonna do some examples in just a little bit of crosses that have codominance, incomplete dominance, sex-linked, and that's going to look a little bit different. In that case, you're going to have to do the entire square. But if you're just dealing with a dominant recessive trait for both alleles, and you have 2 heterozygotes, 2 dihybrids being crossed together, then your genotype and phenotype ratios are always going to be 9:3 to 3:1. Next, let's try another example. So let's have a look at a different example here. So example 2. If one of the dihybrids that we used in the cross before, if one of the dihybrids from above were to mate with a blonde with blue eyes, what would be the phenotypes of their offspring? And then let's do a part B to this. Let's say, what would be the chance of a girl with brown hair and blue eyes? Okay. So we start this the same way that we would start any cross. We're going to write down the genotypes for both parents. So I have one of the dihybrids from above that is going to mate with a blonde with blue eyes. So we have little b, little h for hair color and eye color. And this would be almost the same thing as doing a test cross. Remember how we did test crosses for monohybrids? If I didn't know exactly, if I knew the phenotype, but I didn't know exactly the genotype of my first individual, it would be good to do a test cross to see the same way. Am I heterozygous for those conditions, or am I homozygous for those conditions? So the same way that we did it before, we're gonna have to, the first step here is going to be determine the gametes. And we don't always have to draw the egg and sperm. Usually what I do is I start making little brackets and I say, okay, so for this individual, I know I have 4 options. But for this individual right here, I only have 1 option. The only thing that individual can place in a gamete is a little b and a little h. So in this case, instead of having a Punnett square, what we end up with is a Punnett rectangle. Yes, I could have 4 of these all in a row, but I'm going to get the same results. So why would I draw it 4 times? All I need to do is draw it once. And so I'm going to make a rectangle, and on one side I'm just going to put that one combination, and on the top I'm going to put the other 4. Big B, little h, little b, big H, little b, little h. And so now I can do the Punnett square, or Punnett rectangle in this case. And now it wants to know what are the possible phenotypes of their offspring. So when I look at their offspring, I'm gonna check these out. So these ones are gonna have brown eyes, brown hair, brown eyes, blonde hair, blue eyes and brown hair, and blue eyes. So I have all 4 possible phenotypes. So I'm gonna have brown and brown. So that's a 1 to 1 if I was doing ratios. Brown and blue. Oop. That's hair color. So brown and blonde. And 1 blue and brown. And 1 blue and blonde. Okay, so I have all 4 possible phenotypes. Now the next question says, what would be the chance of having a girl with brown hair and blue eyes? So again, product rule here. So I have a half chance for girl. And to that, I have to multiply what is the probability of me having brown hair and blue eyes. So brown hair and blue eyes is right over here. Well, it's only 1 out of 4. So again, I'm going to put 1/4 there. And the answer there is 1/8 or 13% chance of having a girl with blue eyes and brown hair. Okay, so that's for that. I want to show you another method of doing crosses though, because some people like to do the big giant Punnett squares determining the gametes. It's important to know how to determine the gametes. The way some people do it though is instead of doing it as one large Punnett square, they separate the traits, they separate the genes, and they do 2 separate Punnett squares. So I'm going to give you the same example as above. But I'm going to show it to you with the product rule and separate Punnett squares. So we said, let's write again that we had a heterozygote being crossed with a homozygous recessive. Okay, so then let me do 2 different Punnett squares. So I'm going to do a Punnett square for one of the traits, which is this one. And then I'm going to do another Punnett square for the other trait, which is this one. Okay, so let's look at that one Punnett square. So I have big B, little b for one parent, and little b for the other parent. And then I'm going to do the other Punnett square. This time we're going to look at hair color. And I have big H, and little h for the other parent. So I do my Punnett squares the same way I've been doing them. Oops. Okay. And so it wants to know what are the different genotypes that we can have for the children. So now for this one, we're going to look at how we do that. So what can I have? Well, I can have big B and little b. So big B, little b is going to be what? I'm going to choose a different color. So big B, little b, when we look at this, is going to be brown eyes. So I know I can have brown. And then I can have the brown with this, or I can have the brown with that. So I know I'm going to have brown and brown. But I can also have brown with blue. And then what's my other option? My other option for this Punnett square is the blue eyes. And so I know I can have blue. And then that blue can be paired with this or with this. So blue and brown and blue and blonde. Those are my, so I'd say 1 to 1 to 1 to 1. And now the other question said, what is the probability of having a girl? And now what is the probability of having a girl, we said, with brown hair and blue eyes? So I'm going to look at the blue eyes here, and I'm going to say, okay, what is the chance of me having blue eyes? That's a half. So I'm going to put a half there. And I also need, what is the chance of me having brown? So that's a half. Okay. So I'm also going to put that half there. Okay. So I'm going to say this half is for this. This half is for that. And this half is for being a girl. Okay. And then what I'm going to do is a product rule, multiply the top. 1 times 1 times 1 is 1. And then 2 times 2 is 4, and times 2 is 8. I get the same answer as what I had for the other one. Okay, so some people prefer to do this. They prefer to do it as 2 single Punnett squares, especially when we get into, multiple alleles or incomplete dominance or sex linked. They like to keep the 2 separate and then just do the product rule in between. Okay, choose what method is easiest for you and then go with that. But you do need to know how to, what gametes are going to end up looking like, what alleles are going to go in each gamete. So it's good to know both methods. Okay, so I'm going to show you now one with mixture. I'm going to do one that has blood type and a incomplete dominance, codominance, and a sex linked. Okay, so this one is like a sort of a harder kind of question, but I want you to try it. So try this. Okay, so I have a woman who is a carrier for color blindness, which we know it's a sex-linked recessive condition, right? And type O blood, mates with a man who is colorblind and type AB blood. Okay, so I want to know, let's see what we can ask this question. So I'm gonna say I want to know the probability that their first child, so what is the probability is a boy who is colorblind and type B blood. Okay, so that's the question. We're going to have that. And I want you to try both methods. I'm going to show you both here. So the first thing I'm going to do is I'm going to write down my genotypes for my parents, just so that I have them nice and present in my mind. So I have a woman who's a carrier for color blindness. So she has a normal allele and she has a defective allele. And she has type O blood. And she mates with a man who is colorblind and he has type AB blood. There we go. So I have the genotypes of my 2 parents. And I want to know the probability that their first child will be a boy who is colorblind and type B blood. So what I can do is I can make my gametes. And so in this case, the woman can have XN little I or X little n with little I. Those are the only 2 possibilities. Whereas here with the man, we're going to have XNIA, XNIB, or I can have YIA and YIB. All right, so that's going to end up being a Punnett rectangle again. 2 possibilities on one side, 4 possibilities on the other. 1, 2, 3, and 4. So here I have XNI or X, whoops, again, I, X little n, and Y. And then here I'm going to put the male. Okay, those are the possibilities that I have, and you can go ahead, you can do the Punnett square all inside, you can have that, but I'm going to show you if you're doing 2 separate Punnett squares. So you would keep the 2 conditions separate. I would do my sex link condition on one, and I would do my blood type on the other. So here I have my male who's colorblind, my carrier female, and here I have my AB blood and my O. Okay, and you can do those separately. big N, little n, two little n's, big N, and two little n and a y. Okay, so you can fill out the top as well. So we can have, and I'll show you a couple. Again, I'm going to keep my letter groupings together. So xn, x little n, ib, and I. And then here I have x and y, and ia little I, and so on. And so I'm just going to finish it just so that we see that we get the same results here. Now, if you want to know of a shortcut, because the question is asking only about what are the chances it is a boy, really, when it comes down to it, I wouldn't even need to do the girls. I could just do the ones with the Y and do the boys, because those are the ones I'm going to be looking at. Okay, but now the answer, it wants to know what is the probability that I'm going to have a boy who's colorblind and type B. So I'm going to need a boy. Okay, so this is for boy. And then I need colorblind. So what are the chances that my boy is going to be colorblind? Right here, I have a half. And type B, again, when I look at this, I have 2 out of the 4, or 1/2 again. And so I'm going to end up with 1 out of 8. Now let's have a look up here and see if this is true. Now these are going to be girls. So 4 out of the 8 are girls. So I don't even have to worry about it. But when it comes to the boys, this boy is normal vision. This boy is colorblind, but type A, so it doesn't count. And then, whoops. This boy right here has normal vision type B. This is the one that I want. I want colorblind and type B, which is really 1 out of the 8 that I drew there. So either you can do it this way or you can do it that way. You're going to get the same answer. So it's going to be the same. Okay. Now, tomorrow, what I'm going to do is I'm going to post another version of this where we're just going to talk about a special kind of dihybrid inheritance called epistasis, and it's just a little 5-minute clip that I want to do, but I don't want to give you too much on one day. So you'll get that one tomorrow, and then I'll give you some practice on this as well today. Okay, thank you.